Those Space People, a podcast series of casual cosmic conversations with people working on exciting space projects. So today we have with us two guests, Asithang Mishra and Nitish Kumar. So Asithang is a senior data scientist and AI technologist at JPL NASA, and Nitish is an AI team lead at ISRO, the Indian Space Agency. And I'm super excited to have both of these AI experts today with me as guests, and we're gonna take a deep dive into what they're working on at ISRO and at NASA, and all into the AI world, which quite frankly is very new to me. So, welcome to the podcast, Asitang and Nitish.
Thank you, Rachna.
Yeah, thank you. Thank you so much for having us. And really very exciting to talk on AI as is across the world right now. I think these are very interesting times for AI engineers and data scientists to live in because this is something that is on the edge right now. And every week, every month, there are some new frontiers being pushed. It's very exciting times in AI.
Yeah, absolutely. Especially with ChatGPT having kicked up quite a storm. I guess finally, AI engineer, you don't really have to explain a lot to other people when you say you're working on AI, right? People get it.
Yep.
Again, speaking of AI, it's a very broad term, right? So there's a lot of machine learning. There's also natural language processing, which, since we spoke about ChatGPT, there's also a bit of audio processing tools which are based on AI, which I use for post production of my podcast episodes. And there's also image recognition. When you talk about space, you also have automatic feature detection and a bunch of so many things that come under the umbrella of AI. But so, what areas of AI are currently being focused on at NASA and ISRO? Maybe we can start with ISRO because I comes before N alphabetically.
Yeah, absolutely. At ISRO, right now in AI, it is very exciting times. At the same time, it is also very challenging times because AI requires a kind of technological shift, which also requires a lot of workforce to have this, what I call as AI literacy, which means the awareness about the various risks, the various aspects of AI. Space missions, by their very nature, are very expensive and the technologies to be used generally have people follow a conservative approach because it is a high risk high cost mission unless as AI engineers we are able to prove that AI provides us a significant leap over the current technology and adds a significant amount of value to the missions which is not possible using conventional technologies. People still tend to not use AI in simple terms. But however, I think there has been recently a lot of shift, and the outside world changes are percolating into the space industry. I think the future missions, when they're planned on the drawing board, from the drawing board itself, it has to take care of incorporating AI capabilities, and that will lead to much more dexterous missions, much more productive missions at the same cost. So I think, yeah, so it's very exciting for engineers right now, and it will take some time to convert it into significant contributions to space missions. But I think, yeah, like, this is like the foundation of a future being laid at ISRO.
So I agree with everything that Nitish said. I feel like one point we needed to prove to people why they should use AI and machine learning in their missions, in their projects, and everything. Now times have changed when the same people come to us and say, tell us how we can improve our processes, improve our projects, our software, our systems using AI, how we can make everything more optimal and faster, better. And it's definitely an exciting time. And as you asked, where all AI is being used in NASA, so I feel like it's a big umbrella. It's being used, even though it's an exciting time right now. And I feel I would attribute the success or this time to a lot to models like ChatGPT and in general large language models. But even coming up to this, there has been a lot of different adventures projects that NASA has been working on in missions. They've been slowly pushing for more and more autonomy on their spacecrafts and things and trying to experiment on different things. Definitely an exciting time, but in a lot of different aspects, AI is already being used at different levels. A lot in the ground systems, but also in the spacecrafts, like tiny bits here and there. Yeah, we can talk about more specific things later, but like in general, a lot is happening at this point.
Can you talk about maybe Asatang to any existing missions where I know AI is a broad term, but in any form, AI has already been used. Any popular missions that people have cannot guess that AI has been used on that mission?
I think, so Perseverance, the latest Mars rover, that used AI in different aspects of it. It used some AI in the entry and the landing phase of the mission. And then there's, I think, I'm not sure, I think it uses some AI in automated navigation, but I've, I think I've read that it's not used as much and only used in situations where some human intervention is not possible. So they do have a system, but it doesn't use, and I might be wrong. I don't think they use deep neural nets yet. For that, they use more classical machine learning and computer vision to detect best targets for their to shoot their laser and create a plasma and then study the plasma. That I think they have been using extensively to find better targets. I also know that inspired by all this and all the images that previous rovers have captured, they have, and I can tell you the name of the project called AI for Mars, where they have released a data set, and I think it's a the tag data set where you can actually, and I actually know someone who's worked on this project where they wanted to create a classification data set for the Mars terrain so that it could be used in the future with deep neural nets on board to find better targets for doing science. So that was pretty interesting to me that they're already paving the way for such things. They are working with some chips, I think Snapdragon, I think, where they want to send these chips to the future Mars missions, and um, so I feel there's not a lot. Um, I guess where deep neural nets and all the amazing things that we are amazed by in the internet today as are directly being used there, but slowly we are getting there.
Both of you mentioned that at NASA as well as ISRO, um, AI as a technology has only been gaining a lot more popularity in the recent years. So do you think it's because of popular tools like ChatGPT? Because earlier AI was quite limited to AI engineers and experts like you guys, but now the common public and also the other kind of engineers, the non-AI engineers like me, we've gotten a taste of what it feels like to interact with like an AI generated, a lot of generative AI in the form of ChatGPT. So, do you think this has changed the mood at the space agencies, or has it kickstarted some sort of an large language model revolution at the space agencies? Or yeah, maybe we can talk about that.
I would call it a frenzy because based on what I have experienced. But Nitish, do you want to go first or?
I'll step in here and just say that I think it is space missions in general require a lot of automation, right? It is probably 98% of a space mission is automation. So by that very virtue, we are very close to AI, right? We and ISRO in particular is very famous for cutting costs and have very frugal and cost effective missions. And then AI is our natural ally. It has the ability to do all these things. So I think this is the more fundamental reason why ISRO will be very interested and is very interested into things like AI. And yes, the outside revolution obviously helps create awareness about this. And I think there are various degrees of AI. So, like when we talk about missions in India, space missions in India, they have had certain amount of AI, and it's very difficult actually to quantify. As Asitang said about the missions at NASA, even at ISRO, it's very difficult to point out that this whole functionality or this whole process was governed by AI. Rather, it is alluding or assisting people, augmenting efficiency at a certain stage in a very tacit form at various degrees of the mission already. So, in our rover for Chandrayaan, it is very difficult to say it was not AI. and yet it's very not very clear. You will not find a very clear statement that ISRO has made that it has explicitly used AI. So we are in somewhere in between. I think the outside access to AI, which everybody has now due to large language models, is helping the trend. But I think yes, deeply, space industry is one of the industries that will get highly affected by the automation that AI provides, actually, at various levels.
Yeah, it's a very interesting take because till recently, till maybe I don't know 5 or 10 years ago, in the space industry did not definitely have the most cutting edge products in use. For example, your smartphone or your phone or a lot of gadgets we use every day were way more advanced than a typical satellite, unless it's Hubble or James Webb or one of these really flagship missions. So it's very interesting that now we want to put more and more intelligence on board space systems. For example, we want to do a lot of, we talk about image processing, imaging satellites. We want to do a lot of edge computing. We want to do a lot more fancy things on board. We want to do, I don't know, like sample return missions, the Perseverance, for example. Asitang was talking about, we want to do a lot of these cutting edge things. But for everyday satellites, let's say a constellation. So now constellations are all the rage, a communication constellation or imaging constellation. These are still, to an extent, they have quite rudimentary and basic systems on board, right? So there is very likely a very simple routine. So if you look at the onboard computer of the satellite, there's a very basic command handling routine running, there's a very basic housekeeping routine running, and there's not really much of very cutting edge things happening even now, I would say. But how do you see this being revolutionized by use of AI? Do you think AI would become more and more mainstream? Do you think AI would change it and make all space systems more intelligent? Or do you think it would mostly be science missions or
No, I think that's a very good question, and this is a question I think all space organizations are trying to answer. So we'll try to discuss it in full honesty. Yeah. So the first thing about the technology catch up that space industry does, as you mentioned, that it seems like we there is a conservative approach, and the technologies on ground are obviously seem to have much more advanced stage. So I think that's pretty right because of the risky nature and the high cost inputs for space missions. Only the tested technologies make it there. However, I also want to point out that there are various aspects of space missions that have led to new technologies that are being used every day. And I think Sitang can verify that NASA and ISRO as well has developed a lot of new technologies in various dimensions that has actually led to various innovations and everyday use products on ground. Second thing is, I think the space missions in India particularly are at an inflection point, particularly with the new space policy that has has led to privatization of the space arena as well. So there are a lot of now startups coming up, and this is going to have a very deep impact on the way technologies are pushed into space, because startups by their very nature have this ability to take higher risks, and they have the ability to take the what is of the best of the market, and they can have this gap between the present technology on earth and what we are putting in space. I think startups will close that very fast, because anything that saves them money and gives them more efficiency will definitely be useful. Talking about compute power on space missions, this has been an area which all organizations are working on. And I would put the analogy of a child. You don't want to put something very important or very costly in the hands of a child who has a semi awareness or semi consciousness. But there is a critical point or critical age of maturity after which that child can handle, let's say the driving age is 18 or something, right? And then they can handle this. So I think we are very close to that stage. And as soon as the AI technology and this all the compute technology is to that stage, I think we will be handing over a significant amount of decision making of our missions to them. So I think we are very close to that. I will put it that way. The AI child is maturing, and soon we can have very different kind of missions. I'm very hopeful about that.
And I agree with Nitish that I feel AI is going to change everything. We are already experiencing it right now. how it's become a part of everything that we do all around. Why there's and space industry is just another industry where it's going to be used a lot more. And so I think I mentioned this a little bit before, that we saw a glimpse of that a year ago when ChatGPT became very popular. And before that, GPT-4 was there. I remember a year ago, and I was very excited personally, but no one else like around me was people who were not into AI or in the space industry. They just like glossed over it, and they had, and I was like, guys, this is showing emergent behavior. And people were like, what's that? And but I was like, oh, this is going to change within a year. It's going to blow up. And then I'm not bragging about my prediction capabilities of technology, but I was already holding my breath when ChatGPT came. Everything changed because now people could interact with it. It was not just like a model where which is just a language model. It was a language model that can interact with people. So that changed everything because it was in the public arena. Everyone was like shouting, oh, it's so smart, it can create poems, it can, language is amazing with this. And then uh, people are finding all sorts of use cases. And similarly, space people being people like any other, they were also like, oh, can we use this in our everything that we do here at NASA JPL? And so this question was being raised so much at JPL and a year ago, roughly. And because of that, we formed two different committees. Yeah. So two different teams or two different groups. So one of the group was basically they wanted to understand what are the different use cases within JPL or Jet Propulsion Lab. Just wanted to mention JPL is generally, I might say it multiple times, and a lot of people when I say JPL, they're like, oh, JBL, the speaker company. But yeah, JPL, Jet Propulsion Lab, is one of the NASA centers which I work for. So the first team, we wanted to understand what are the different use cases that can come in the space industry and specifically JPL. Uh, and the other team was very much interested, and this other team was a lot of data scientists. So we were very much interested. We were having this itch of we want to build something on top of AI. So we wanted to do a lot of prototyping on this. So both these teams started working parallelly to understand. And after 6 months, it just blew our minds as to how many use cases came out of this exploration. And later on, I gave a lot of talks on like where I summarize all these different. So what was interesting was that there were some things that everyone was asking for, literally. And then there were other things which were very specific to the different divisions and sections or different domains that people worked in within JPL, be it technology, be it science, be it earth science, be it planetary science, and these different areas, and robotics, which again JPL is very popular for. So everyone was basically they had their own ideas of, oh, we can do this with this technology. And the people who didn't have this clear picture of what they can do with a large language model, they were asking us. And meanwhile, we were developing prototypes and talking to other people. We were suggesting these new people as like, have you thought about this? You really, and there were very interesting things. Like someone basically suggested, and this guy was a robotics technologist, and he's we a lot of people get old, they retire within JPL. They have a lot of knowledge in their heads, and when they retire, a large part of that knowledge base goes with them. A large part of that experience goes with them, and so they're like, can we capture this knowledge explicitly somewhere in maybe the communications they have done, the work they have done, the slides they have produced, and everything? And can we create a digital twin where like we can use that for missions? And then they were like, we have so much documentation about every mission in so many modalities. We have databases, again, we have slides, we have PDFs, we have reports. And only if you have as a person an experience with the previous mission you can bring that knowledge over to the new mission. But if you don't have that experience, you maybe a lot of times reinvent the wheel, you start anew. So can we just somehow tap into this knowledge, and new missions could actually use this previous knowledge, and we can ask questions about, oh, we're facing this problem, can we solve it? How was this problem solved in the past? So I think the biggest thing with ChatGPT or large language model that opened up was this idea that Now we have this huge knowledge base somewhere, and now we can access this repository of knowledge. It's in our fingertips. But can we do it with the space knowledge? Can we do it with academic knowledge, like our local knowledge, rather than literally everything on the internet? We're like, as scientists, we don't care about that as much, but we care about the knowledge that we have collected, and we use it in the same way smartly. So that was the biggest ask and the most exciting thing, that everyone was like, kind of just like, let's do this.
That's an amazing use case. And I think it's very important, especially for the space industry, because this is the reason why the Apollo era cannot be replicated again in today's times, because there's a lot of knowledge that's lost with the people who retired or who are no more. So this is pretty amazing. Is there a public archive, or is there a public, I don't know, a website or a web page where these kind of offbeat use cases where NASA scientists have brainstormed are put on?
We were doing it internally. We were maintaining a lot of records of. So we had we started doing it in like things similar to Google Sheets, where people can collaborate. We had a list of like hundreds and hundreds of different use cases, and we would ask people like, "Are you in robotics? Are you a chemical engineer? Are you a geologist? Who are you? What's your background? What do you do? What's your role for JPL?" And then they would come up with a, and then in the end of 8 9 months, our job was to sift through all that knowledge, and then we interviewed people all across JPL, and we still have those transcripts. So I know those exist within JPL internally, and then our job was to summarize everything, categorize everything, find out patterns, find out what could be done, what's impossible, and if there's a huge use case. And I remember someone actually came up with a huge use case for engineering drawings and like systems engineering, and so we had to break down those use cases into some bite-sized use cases and like such recommend things. So I guess short answer long, I or long answer short in this case, that it's there's a it exists internally, but I think it would be super exciting, and I might talk to some of my colleagues to maybe push it. Actually, we presented some posters conferences where we summarized a lot of things, so I can send you these. So part of it is present in the public domain, actually, the summarized version of it, not the chaotic, full-fledged, comprehensive brain dump of all the JPL engineer and scientists and everyone.
And did you also run it through ChatGPT to summarize it?
Oh my God, that was the most exciting part. We wanted to say, okay, we actually did it. We took everything, we ran it through ChatGPT, and we asked it to summarize everything for us. And that was, so we were doing all sorts of crazy things using ChatGPT and similar large language models.
Yeah. Yeah, I completely agree with both of you, right? Nitish, you were also saying that AI catches up so quickly, because every time I use a bunch of AI tools to generate show notes and for, I don't know, chapters and everything for my podcasts. And every time, so every 2 weeks, I access this tool, it gets better and better. And it's crazy. It's
Yeah, like one of the things I'll just step in and point at this what Asitang was discussing about the knowledge base that employees have. ISRO has a similar program called the Human Library Program, where we actually have people who have a significant amount of knowledge and are nearing superannuation. We try to pose as many questions to them, and those answers are recorded. Yeah, because this is a very niche area and a lot of valuable information is there. And recently our director also had a program where he actually called the retired people, and they came, and it was a continuously went for I think 3 months. Various different departments called their seniors and they questioned them on various aspects of the space mission, and this was revitalizing the whole knowledge base again, right? So I think, yeah, that is like one of the very important use case, and we have all the answers and knowledge base in the digital form. And internally, because we cannot use chat gpt in ISRO, we have this thing that we have recently developed called Gyan, which is equivalent of what you can call as the GPT within ISRO, with additional tools, specialized tools for ISRO. And we have this knowledge base there, and it's very interesting to see the questions people pose. Also, I would like to point an interesting incident anecdote basically that happened is we were sifting through the library records of what kind of books people are taking out over a period of time. and it's very interesting to see this over 30 or 40 years of data. And we see this huge shift. Like there was a time when pioneers of space in India like Vikram Sarabhai and Abdul Kalam and UR Rao, these people were in office, and people at that particular era, the books that they were checking out from the library were not only technical books, they were books all around of all interdisciplinary books. Basically they had books from sociology, nationalism, politics, even psychology, thermodynamics, economics. And I was so shocked, like the type of books they were reading. Now 20, 30 years later, one of the shifts that I see has happened is the specialization of different departments has become so deep, right, that people just check out mostly technical books. And that kind of shows the difference that has happened over time. These are also some of the things that you can do with AI, that earlier was not possible, that you can actually bring out some very interesting patterns. So that was another thing.
That's very interesting. Just to interrupt you, Nitish, a bit, because Asadang, when you mentioned the digital twin, I think having one parameter being the library books a person checks out really completes their personality profile.
Yeah, I agree.
Yeah, and I think so. Like one of the things we were discussing was about the. So I want to bring up this topic of about getting more and more intelligent that we are discussing over time. I think it's like a chain reaction. This growing of intelligence is like a chain reaction, and there is a critical point at which suddenly it becomes useful for so many things. Okay, and it's very difficult to point out that okay, this is the point. But if you are behind this point, I have noticed, especially with large language models, which I hope we'll discuss in detail. But I have noticed that there is a certain point of data or certain point of text that you feed to LLMs or any other models also, and after which they suddenly become very useful and they start beating all the human standards also. And before that point, they are quite bad. So I think that's going to be a very interesting area of research, how to narrow down on the critical point. It's very interesting, and I think all the AI engineers have had this eureka or that euphoria moment where we saw these emergent properties. We were not expecting these properties, but they are emerging in a very coherent manner. So that was very exciting actually. In the last 1 year, I think this was the most exciting point for me in AI.
Given that AI is catching up, is evolving so rapidly, like you said, how can a space professional, someone who's already working in the space industry but has not really worked with AI or any kind of machine learning algorithms, so basically someone like myself, what kind of basics or what kind of toolkits should they get familiarized with so that they could work alongside AI or AI experts eventually?
So I feel like if you wait for 2 years, you won't have to learn anything.
I would have a job as well. So
So you just have to command the AI what you want to do, and be like, can I get this analysis done for me? And to be honest, I'm not even like kidding. Like part of me is very anxious. I mean, kidding. I'm not, but I feel like the first people to go out of job will be data scientists. But the the thing is, it's true that with all the development of AI, everything is going towards an subject matter expert. So if you're a subject matter expert, then you have a lot of power to you. And I think that's the purpose of data science, is to make so that not everyone needs to do data science, not everyone needs to write algorithms, not everyone needs to do a lot of heavy coding. And we are going towards it really fast with the AI and stuff, and some of the things that AI has recently led to. We can go in more details, but to answer your question, Rachna, I feel like for me personally, technically speaking, and from the perspective of a skill set, Python has become a very important language. So I tell this to everyone: is if you want to learn one language, learn Python, at least from the current perspective and how important it is. For AI, I feel like you can enter AI from different perspective. If you want to learn, you can either go from a very mathematical statistical perspective if you're a lot of inclination towards that, and you can learn the very pure mathematics behind it, how to write the algorithms and how do they actually work. But you can also go from the semi user perspective, where you have a project and you want to learn what are the basic steps of a machine learning algorithm, where you have a tagged data set, then you do some learning, the model is learned now, and then you do a validation, then you do a testing. Even someone who cannot write algorithms, you can still understand the basic steps of how machine learns and things like that. Or you can even do access libraries like sklearn and such, where if you understand a few basic ways of invoking some functions and understand that there's a fit where you're fitting the model, there's a predict where you're predicting on new data. So you're not really writing an algorithm, but you're still doing machine learning there. So it's basically based on how much time you have, how much interest you have. You can enter AI and data science in so many different levels that it's just amazing. It's mind blowing to me of how accessible this is at this point.
So it's going to become like, I don't know, Google Sheets or an Excel sheet.
Yeah, it's going to be very democratized, and that's one of the like fun things for this. It's a scary things for companies and industries who maybe want to have some monopoly over the whole process. But for normal people like us, it's super exciting.
I'll just step in and add a point here from the purview of space scientists. What Asitang told are the absolute steps that you have to take: learn Python, learn about how to use the machine learning from as a utility tool. I think I'll add a point for space people that you also have to learn how to establish guardrails. With machine learning, you have to be very aware of what are the limitations, because as they are data driven systems, as I call machine learning as wisdom from the data, it is learning all the wisdom from the data. So you have to be very careful that it is not operating in a situation where it is not corresponding to the data on which it has not been trained. Basically, let me rephrase that. You don't want your machine learning models to operate in a scenario whose data you have not used in the training. That's a very tricky business. So I think these are some of the basics things that you need to be aware of if you want to use AI. However, as I'm very impressed with Asitang and the way he has developed AI, so that is like a totally different skill set. Then you need to know the mathematical, all the operators, and to a different extent. However, as a user, it is quite simple, and the most important thing is to understand the limitations of AI.
Speaking of limitations of AI, right? I guess it's also, at least for now, majorly limited when it comes to working on any sort of hardware. So space mission, for example, is you're actually, it's a satellite or it's you're building something. It's a hardware, it's a piece of hardware that has to be very reliable under very extreme conditions, space conditions, right? So I guess this probably, I don't know, is there, do you see a future where um, AI could also help in a lot of the hardware design? So, because for example, right now I am an embedded engineer, right? So I'm part of the onboard team, onboard data handling team, and then I write a lot of, let's say, low level drivers, low level firmware, and I'm taking. So how the flow works is basically my engineering team, they design a new onboard computing board, for example, or they assemble something, and then they give it to me to do some tests and to run the algorithms. So there will be 100 million problems with this board because a lot of times the solder is bad, there's a lot of hardware issues, or the data sheet is not correct, or it's not updated, or so many issues where I will have to go back to the lab and use my oscilloscope and then test, put probes and do a lot of hands-on things. So do you see a future where AI could also help me, at least if not replace me in doing this, but at least help me in finding the problem sooner?
I think yes, the answer would be from my perspective at least, because and I always say that space industry is very high risk and it's like literally mission critical. So if you just let AI do everything, that's I don't see a time where AI is going to be just doing everything in complete autonomy in space. But still, the interesting part is that it doesn't have to do everything. And as you said, Rachna, that's the most exciting part for me is the assistance that comes from the AI for the humans to do their job faster. Um, in kind of as you said, particular scenario where you work, um, I feel like I'm not a complete expert. I'm not an expert in what you do, but in general, in hardware, there's a few things that there's few use cases that I've come across that are very interesting. When you build systems and subsystems for a mission, there's a lot of hardware building, there's a lot of software building, there's a lot of integration of these two. And then at least in JPL, there's a problem reporting system where you report everything that you've all the issues that you're facing. It's done in natural language, sometimes shorthand, but you fill a form then, or if you detect an anomaly during integration testing and some test fails and things like that, so you have to report and write the reasons. Someone comes and solves it, which engineer came and solved the problem, how they solved it. So a lot of these things, a lot of the space industry, they document it really well, but it just sits there, this data. No one uses it as a knowledge base again to see if a similar problem arose, who to call, what kind of skill set will be needed, or can we actually detect based on the previous experience what problem this might have caused, what system failure might have caused this particular subsystem failure, what to really look at during this. So, doing this root cause analysis based on the previous knowledge of the engineers like you who are actually building things. So that was one amazing use case that within JPL people are actually started working on. So the other thing is, I think, a robotic arm. So there's people have done some amazing things. I think there's a the paper by DeepMind, I think, where they have used the large language models, where it actually spits out low level commands for a robotic arm. So you give it a task, and then it starts spitting out low level commands for the arm to actually be able to accomplish this task. But not only that, there's like now a more of like closed loop in a closed loop settings. You can ask a robot to do something, and then it's also aware of if it's failing or if it's succeeding. So maybe there'll be a helper arm around you for you to command it to say, give me this thing that I need, or can you solder this thing, or can you hold this thing while I'm doing this? So it will be your tiny helper that helps you in some way. Or maybe the more repetitive things. So it is already known that for a lot of repetitive things. So the interesting thing is that so this was low level where you give it a command, it can give you a low level sequence of things that if the robot executes, it'll be able to accomplish the final task. But then, because LLMs they very much deal with language, which is very high level, not only, so you can give it a command and you can see it in real time thinking as to, oh, I bumped into this wall, maybe I should go back and then help Rachna all over again. So it knows that it has failed based on all the different feedback it's getting, which is a video feedback, it's the image feedback. It's also you might be telling in the loop saying, don't go towards this wall. I told you to come here, not there. You can do all these things, and it's in real time. It will take it as a feedback, and you can see it thinking. Rachna told me to not go towards the wall, so I'm backing up. And these are so people are having a lot of fun with this type of model. Even in large language models, you don't have to do any changes to be able to use them for robotics. And there are frameworks which I think called React frameworks. Nitish, let me know if I'm doing wrong anywhere.
Let me react to that.
Yeah.
And yeah, so obviously React is reacting to the environment around it, consists of 4 or 5 steps where it takes plans out action, higher goal, it breaks down into sub goals and then executes a subtask and sees if it is going in the right direction, and so it keeps going forward. And that's what I think he's pointing to is LLMs have this ability to not have a coder in between to convert the high level plans or the human level plans to code level execution. You have now large language models which can actually take the input in natural language.
So once they have planned it out, they can actually write codes to execute those plans automatically, or they can access other tools. So it's a great integration point.
Yeah, one thing that I want to point out is a very subtle thing, that is AI is very good with the digital world right now, and it is not doing absolutely great, like you told, in the physical world, right? That was a word you used in the medium. So there is a very clear reason for that, and the reason is there are not enough sensors. So let me explain that. When a human being operates in the 3D world, they are made up of amazing sensors, and they have been training since childhood in the 3D environment. And there are a lot of cultural things, intellectual things that they have learned along the way, the concepts that they have developed. These all are subconsciously working together when you perform a task in the physical world. All of these are not captured in data, right, and fed to AI in the whole totality, and that's where the difference actually comes, right? So that's why the if you have a robot trying to do something, it will do a hit and trial and then work it out over a long period of time. Maybe since childhood we have been doing the hit and trial, and we have already reached that stage, right, all of us. So that part is somehow missed. And also, for AI to operate in the 3D or the physical world, it has to understand a lot of the human nuances, because we do not say or speak everything in detail. Like, we have shared concepts, we share similar disciplines, so there are a lot of unsaid things which the AI may be missing. So I think those are the gaps actually, that limits AI to come into the physical world. And as Asitang said, I totally agree that right now beings are the best bridge between AI and the physical world. That assistive AI will be, whether it is in medical science, to have robotic surgery, space, highly complex space maneuvers or missions, you need to have human assistive as of now, as of speaking today.
Absolutely, yeah. There's a lot of context missing for AI, and it's only a matter of time it gets there. But yeah, I absolutely love it. I'd love it if a robot can take over all the soldering and even harness making. It's such a pain to build a harness. So I would really love that. But from all that you spoke about LLMs, looks like there's so much more to large language models than just being the face of AI, for example. There's so much that it can accomplish.
Yeah, and sorry to interrupt you, but I
I think Asitang gets really excited when we talk about.
do.
LLM is the magic word, you know?
And I'll tell you why. I'll tell you why. The reason is that this is the closest thing to artificial general intelligence currently. And so this is basically the matrix that is like connecting all the other AIs around it. Like visual large language models. Now they've integrated vision, like things we can see in around the world, and language into the same latent space or into the same kind of space. So the understanding of language as well as visual things are connected now in VLMs. As Nitish was saying, I believe that like they are already very powerful in understanding the world because there has been a lot of very powerful models which understand what it's seeing, like for image captioning and other things. They have come a long way. Now folks have just merged the large language models with vision models, and now it can understand, it can see. So I think ChatGPT 4, there's the vision model where it can see graphs, it can do analysis on graphs, and it can understand pictures, and you can talk about it. Now it can also manipulate things because it is a generative AI, so it can even generate new images. As you can see, Adobe has released a lot of things in Adobe in Photoshop could be done using completely AI. I think all these separate things are merging now because of large language models.
I think, like, we should also just discuss the why it is so, and that's very important, because most of the other things, the vision and other tools, they are not very expressive. Means we do not have a way to interact with those models. And what is very exciting and about large language models is, for the first time, you can actually interact with a AI model, right? And that gives you so much more room to get things done. When you're able to query it, you are able to ask it questions, and all human thought is in some language, right? And when ChatGPT is generating some language, I think we can say that it is generating thoughts, because it is generating some of the sentences or some of the plans on which it has not been trained, right? So we can also say that it is generating new thoughts. And that's what, like Asitang was saying, that it is about the artificial general intelligence. That's the expressiveness and the interactability has increased so much with LLMs. It can be used with all other models also, and it makes them even more useful.
Yeah, and it also acts as a sort of a positive feedback, right? Because the LLM, the chat GPT, for example, is also learning because now it's you're asking it real, it's learning how to solve real problems asked by real people, which really beats any kind of data set that you can feed into.
Yeah, I want to clarify 2 points though. I think it has general intelligence, so it doesn't need to generate new thoughts to emulate humans. So it's already artificially pretty well at this point. The generating new, can AI be creative? That's a very current area of research in cognitive science, which is very interesting. Actually, me and Natish have talked about this like separately, but so these things are happening right now. Now, people in neuroscientists and cognitive scientists, they are getting very interested into AI and saying, can we poke things and see if it's does it have theory of thought, is it, I think, and does it is it like, is it really thinking, is it, can it be creative? And then they're like, what does it mean to be creative at all? And so it's exciting because we have this thing that we don't completely understand as to how it's doing and what it's doing. We do understand kind of the mechanics of it, but then we ask ourselves, is there more to it than just the mechanics of it? And then as humans, did our brains also develop with language? So was language kind of one of the first steps of the development of intelligence, which we are seeing in AI? This thing where the language like, language models are very simple things, very basic things. And now we are seeing that just by learning a language, predicting the next word, you get something that is seemingly super intelligent. That begs the question, as humans, did we just develop language and then that led to some sort of intelligence? So, again, I don't know, but exciting.
So let me tell you an interesting fact that Asitang mentioned, that building the bridge between AI and cognitive sciences. Actually, in MIT, they have actually built a physical bridge between the cognitive sciences department and the computer science or the AI science department. So, like, that is literally there are a lot of bridges being built. We can say that literally between these two departments, and this is very exciting times in those sense. Also, there is a lot of value to having thoughts. Like, people who do things which involve the thinking or thought process are generally paid more than the physical labor, right? So this is like established fact. So the whole knowledge economy, the people who are actually doing the thought provoking things are adding more value to the economy. In a sense, you can say that from that point of view also, it's very interesting to have AI, even though it is not currently, I feel there's still some time to go into to come into the physical realm. Already there are a lot of things happening in the thought realm or digital realm where things are more subtle for AI to play along.
Absolutely. Circling back a little bit and going back to how AI can be used in to solve problems in space. So, two of the biggest problems plaguing the space industry or the space sector are currently modeling of space debris, accurate modeling of space debris, and also space traffic management. So, do you see a timeline? What timeline do you see where AI can really help us model space debris more accurately, or completely taking over space traffic management and making space safer and more maneuverable to all of us?
I'll just answer from the perspective that right now it is very difficult to predict the growth of AI. It is going to be sooner than whatever number I say, I think, right? Because every week or every couple of weeks, I get or I come across some news article or research article that actually surprises me. Oh, we're already there. So whatever number I say, it is going to be earlier than that. And I think the space environment, there's going to be an explosion of intelligence, as we discussed from the beginning. As soon as things start to mature to that level, and I think we are like close, maybe 18 months away from that kind of scenario. And once we have AI going and controlling things in space, it will just be a huge explosion of AI agents into space. And then I think managing space debris and like space traffic management, these can be done at least theoretically much better and much more in real time by AI than by having people on respond to a situation in space. So obviously there is a lot of potential there. However, I think the actual implementation depends on other factors also. The policies at space organizations, international collaboration together in that area is another aspect, because this affects the whole globe. And also the budget push that is given, and how seriously the world leaders are seeing this as a problem. So besides those facts, I think it's like 18 to 12, 18 to 2 months to 2 year, maybe a good timeline.
I agree with Nitish, but I also wanted to say that my gears were turning when you asked me this question. I I feel that the space debris modeling problem could be solved. I mean, you need to first sit on that problem, and like someone needs to decide to put enough money into a model, first of all. And so I agree with Nitish. But the technology is already here because, again, going back to my favorite thing, language and language models. So the same technology that has spurred the development of so many amazing models in the recent 5 6 years, it started for just modeling language, and now the same technology, which is transformers actually, it's used for modeling literally every modality of data. So the space debris problem is just another type of data. Maybe you can model it as a time series data along with some, and mostly that's what I would think of at least. But you can throw in other modalities into that as well. So because you have that, you can actually train a model, perhaps the same underlying technology that has spurred the generative AI movement. So you can actually very well, at least in theory, you can model the space debris using the same technology. And again, and as some sort of a generative model, I'm guessing has to be a large model and maybe pre-trained on like simulated data, but then maybe fine-tuned on actual space debris data. And the other point is that I think I forget which mission, they're already looking into collision avoidance in satellites, so avoiding the space debris. So even there, I feel like all the things like reinforcement learning, large language model based React thinking, step by step thinking of how to, or like generating low level commands for maneuvering around things based on the situation. So all these things are already, you can see these are being automated on the terrestrial level in robotics as we speak. So I think this could be applied pretty easily to space.
Completely agree with you. Anything gets done in the space industry either because of political will or a business case.
Exactly.
And what kind of roles do you see? You mentioned, Asitang, you mentioned that data science jobs are the first ones to go very soon. What kind of roles do you see in the space industry getting taken over, or okay, not taken over, it sounds a bit harsh, but being automated or taken care of by AI in the near future? So I would say mission management, for example, probably would be one of the first ones.
Yeah, I think anything that is repetitive and where there's a lot of, so for sure where there's a lot of like where there's a lot of reading of papers, like reading involved, first of all. If you have a lot of policies for missions and there's someone who's reading all the policies, there's an army of interns who's reading the policies and seeing if they apply to a particular current mission and the compliance is there. This is just one example. It's also an example that I've worked on so one of the initial prototypes. So there are people who actually read these very dense policies and see missions are actually adhering to these policies. And and then it's a pain even for people who are actually doing it. They need a lot of, so I don't think employments as such are gonna go away. It's just things are gonna get really easy for people. And I believe that the in short term, the lot of jobs will get obsolete, like filling forms, filling Excel sheets, anything related to language, which is repetitive, reading things and then like summarizing and things like that is going to get obsolete. But in the longer run, more jobs are going to get created because then people would want to do more and more creative things. And so a lot of creative jobs are going to come up around those. So I feel like the future is not completely dark.
It's net positive.
It's a net positive.
One of the ways in which we can put this is the currently whatever is the nature of jobs, it has a certain machine element to it, where human beings have to deal with machines and they have to be like machines, more or less. Let's say it out. I think jobs are going to become more human, you know, where the human component is going to be significantly enhanced, and they are going to be the focus of what we do at work. And in that way, I think jobs are going to be much more meaningful. Our productivity, our efficiency is going to be much higher. So I think future is looking bright actually in terms of employment. I don't see it in a negative way, that it's going to be, because as Asitang mentioned, in space industry, and I think that applies also to all other big industries, you have this whole army of people who are who are just making sure that process is compliant. They have the previous knowledge applying to the current missions, and actually it is not actually having any effect on the real things on spacecraft. They're just doing this whole bureaucracy where things are just getting verified, and 90% or 99% of that job has very few translational effects or transformational effects for the actual mission. So I think that is something that will be interesting to see go away. I'll be very pleased actually.
I love what you said, the way you said it, Nitish, that jobs will become more human. So that's a very positive, nice future to look forward to. Yeah, Satang, I wanted to ask you because given the you're working at JP, you've been working at JPL, so there's also these ITAR regulations in place that I wouldn't say prevent, but make it very hard for non-American citizens, non-US citizens to work in this sector. But you were working on AI. So does it make it any easier or any harder to get all the permissions or to jump through the loops?
I feel if there's a will, there's a way. But I feel there's always a way to go around these things or bypass some of the things. And but I have mixed feelings about this. So on one side, I feel like when a space agency, and I understand the political reasons behind having ITAR regulations and all these very heavy regulations in place, but I feel like feeling from the perspective of being a global citizen and that it thwarts your progress as an industry. And I feel a lot of times why the tech sector does so well is that they don't have these things in place. They just go for it. If there's a skill, there's a talent, they would use it to the best of use. And the talent, wherever the talent comes from, whichever country or whichever background, they have the right to contribute. Unlike when you have things like a lot of heavy regulations in place, then there's always this thing that, okay, the talent might think that it's taking so much time for me to contribute to this particular sector. Might as well go to somewhere else where I can contribute right now. So there's always these things which discourage people from coming to places like NASA, or I'm sure ISRO also has very strong kind of guardrails against people who are not Indians or and how they can contribute, what they can access, and things like that. But I feel like, again, understanding the political side of it, I feel if people want at NASA or at ISRO or any space agency, they can do a really good job at making sure that they understand which parts of the technology could be developed independent of these regulations versus which parts should be secret or they shouldn't be allowed. And in my experience, those parts are very small. And another aspect of being a very big proponent of open source, I feel that from experience, the industry and everyone has learned that open source things remain, they develop, they get a lot of eyes, get a lot of focus, they don't go obsolete. If they go obsolete, you know that they have gone obsolete. You don't get to know after 10 years that they are obsolete compared to a lot of space industry where 20 years later someone, oh, this code looks so obsolete, can we renew this? No, you'll know in the next month that this is not working. If it were an open source part, like in the open source, people can contribute because there are a lot of people who are so enthusiastic about contributing to such things, and a lot of regulations are not helping. So I think the US government is realizing this pretty fast, And I think there was some sort of a directive or order at the beginning of this year where they wanted NASA and other government agencies to make as much as things open source in their code base. They want so that they can flourish, they can develop, they don't go obsolete. So I think the government is realizing it. Now I think, so again, it's happening slowly, but I feel like I've seen both sides of it. It's easy if you're working with the right people, with the right mindset within the organization. But I won't say the whole organization has the same mindset. There always will be people who will be like, I don't think foreign nationals should work on this project, this particular thing. But again, I think differently from such people. I feel like people should be able to contribute. And also, different agencies should share their knowledge, their technologies, as long as it's not like a weapon or something. And it's been shown that things actually, and again, I guess I'm repeating myself, but I feel they should learn something from the tech industry. Yeah.
Yeah, I guess at ISRO, at least, you cannot really be employed by ISRO if you're not an Indian citizen. Nitish?
Yeah, that's absolutely right. Yeah, and there is a thorough background check, and I think that is like in most of the strategic areas, including ISRO. Yeah.
Nitish, you're an AI team lead at one of the ISRO centers. So, how big is your team, and are there such teams dedicated to AI across ISRO centers, or is it only at URSC that something like this being done?
We have teams at various centers, and these teams are getting more and more crystallized, as time is passing. There is a definite structure to them as time is passing, and I'm aware of like many very good teams across India, which we generally interact with them through headquarters, ISRO headquarters, and their programs. So at least 17, 18 teams are there, and they have developed expertise in different areas depending on where they work on. Like there are people who actually work with the payload data and imaging, radar imaging, and so on, earth observation and mapping, and so on. So they have this whole very good people in image processing and so on, real time image processing and so on. We at URSC are specializing in various areas of the spacecraft, including the health monitoring, the robotics. The large language models for us is very interesting in so many applications. Similarly, I'm sure there are other teams in diverse areas that are coming along. So this is going to get much more get a very clear structure, I would say, in the coming times. But yeah, there are teams that I know of.
A repository or a public source where we can find what kind of AI projects these teams are working on?
Yeah, so I think ISRO headquarters is aware of, and they're coordinating with all the different teams at the national level, I would say. And they have published compendium of the latest developments, I think, with which is a team at headquarters that does that. So you can find the projects which have neared completion or are declared. But there are a lot of teams at the same time. I would say that this is just the tip of the iceberg, because there is a lot of team that are they're still yet to declare themselves team, and they're still working out on some problem or the other at their level. And that is a lot of exploration is happening with AI and their latest developments right now.
Okay, cool. Yeah, I guess we've covered a lot of aspects around AI. I've learned an incredible amount of things. I also have to now go back and Google a lot of things and maybe do a short course on Coursera on AI. It's so interesting. Thank you so much, Asidang and Nitish, for your time. Thank you so much for the insights. I loved the session today.
Thank you, Rachna. Do reach out if you have any questions after this. We'll be happy to. It's always exciting for me because even when I'm helping someone find things, I myself find something very interesting that I haven't yet learned in AI.
Absolutely. Yeah, I would love to. And you might regret that offer because I might bombard you with too many things. But if young space professionals or enthusiasts want to get in touch with either of you, what's the best way to do so?
I have a LinkedIn profile where I do entertain a lot of serious questions from people, and I think every month I go through it. So that's. But I do have my email, which is asatang asitang.edu@gmail.com, which I have made for this purpose because at one point I was getting a lot of questions from students and stuff. So that's something where I feel like it's okay as well if they email me. And somehow I think uh, people are able to find my private emails and stuff, and they email me, which is fine because a lot of times they're like, these are serious people, so I've not gotten a lot of spam kind of people. That's fine.
I have a LinkedIn profile where I entertain both serious and non-serious questions. Very serious ones. So you can reach me out there, and obviously it is a lot of fun. Also, before we close, Rachna, I just wanted to share with you guys that some of the applications in AI are so mind-boggling. Recently, we have some of my friends build up an application that actually uses the ancient Vedic texts and use them from for astrology, basically. And they use this text to read this text and give astrological insights into. So that is something that these kind of use cases and fringe elements are always so exciting, because it requires otherwise so much cognition to just go through all this text, memorize them, and apply all this to a person's details. So that's always very interesting to have these kind of applications.
There's no limit, I guess. It's a very exciting future to look forward to. And thank you so much for your insights, guys.